Metamaterials are a new idea really since about 2000. The concept is, if you imagine a wave on the ocean, for example, of a wavelength about so long, and if that wave interacts with something which is big, then it sort of scatters off it. But imagine something quite small, smaller than the wavelength, then that can be considered to the wave as an atom. It's much smaller than the length of the wave. Now, when we look at light, the wavelength of light is very small, so the things which make up structure, like in glass, the atoms, are tiny relative to that, and that's ordinary atoms. But if you take microwaves in your microwave oven, the wavelength is much longer. So now we can design structures which have got properties which are not found in atoms. So we make meta-atoms.
Primarily our metamaterials work is looking at microwave surfaces to control microwave signals. Your mobile phone does that. It sends signals via microwave to your base stations, and so we want to be able to manipulate microwaves more effectively, steer them and beam them, so we do that. We're also working with companies on acoustics. Acoustics covers simple noise. Our lives are polluted with noise. It also covers ultrasound, scanning of babies, for example, and how we can do that better, perhaps. And thirdly, we're working with a fluid flow, looking at how we might control fluid flow better for quieter ships, less energy consuming vessels perhaps, maybe even extracting energy from the ocean.
There is a wealth of brain power. We've got some very bright youngsters who are willing to think out new ideas, so that's advantageous for the industrial investors. There's a potential, of course, to link in, to talk to the students, to get to know the students, to look for future employment. And that's really helpful. Many companies struggle to find really well qualified, suitably trained students like ours will be. They'll be not just trained to do research, but they're being trained in other skills as well, deliberately communication and so on. So these will be a particularly good bunch of students to employ.
Because of the relationship that we have with industry, we have a very backwards and forwards relationship in that we do a lot of the basic research for them that they could then take on board. They have a considerable amount of more funding, and if there are any ideas or any progressions that come from our research here in the university, from PhD students or postdocs, then they are able to take this forward, possibly make something commercial out of it, or make some more progressions that we're not able to in-house here at the university.
We don't have a vision of 3-4 years. We have a longer vision of maybe 10, 15, 20 years. Some of our research coming through to real advantage to the nation, to the economy. That's what it's got to be. You can't do a creative piece of physics research today and hope it's going to produce money necessarily in a few years' time. Magnetic resonance imaging is a case in point. Developed at Nottingham University really 40 years ago maybe now. It came to profit, I suppose, after 15 years, maybe more, and now it's used in every hospital in the country. That was a physics development. There are things like that which will come out of what we're doing, which we can't necessarily see, but the impact on a company and the nation in the longer term could be enormous.